balancing to optimize lubrication. A problem with rotary engines is that the engine housing has permanently cool and hose surfaces when running. It also generates excessive heat inside the engine, which breaks down the lubricating oil quickly. The Sparks system reduces this wide differential in heat temperatures in the metal of the engine housing, and also cooling the rotor from inside the body of the engine. This results in reduced engine wear, prolonging engine life. As described in Unmanned Systems Technology magazine, SBARC is a sealed rotor cooling circuit consisting of a circulating centrifugal fan and a heat exchanger to reject heat. This is self-pressurized by capturing the blow-by past the rotor side gas seals from the working chambers. 51, 52. Creve is an exhaust reactor, containing a shaft and rotor inside, of a different shape to Wankel rotor. The reactor, located in the exhaust stream outside of the engine's combustion chamber, consumes unburnt exhaust products without using a second ignition system before directing burnt gases into the exhaust pipe. Horsepower is given to the reactor's shaft. Lower emissions and improved fuel efficiency are achieved. All three patents are currently licensed to UK-based engineers, AIE, UK, Limited, 53, 54, 55, 56, 57, materials. Unlike a piston engine, in which the cylinder is heated by the combustion process and then cooled by the incoming charge, Wankel rotor housings are constantly heated on one side and cooled on the other, leading to high local temperatures and unequal thermal expansion. While this places great demands on the materials used, the simplicity of the Wankel makes it easier to use alternative materials, such as exotic alloys and ceramics. With water cooling in a radial or axial flow direction, and the hot water from the hot bow heating the cold bow, the thermal expansion remains tolerable. Top engine temperature has been reduced to 129 degrees C, 264 degrees Fahrenheit, with a maximum temperature difference between engine parts of 18 degrees Celsius, 32 degrees Fahrenheit, by the use of heat pipes around the housing and inside plates as a cooling means. 40. Among the alloys cited for Wankel housing use are a 132, Inconel 625, and 356 treated to T6 hardness. Several materials have been used for plating the housing working surface, Nicazil being one. Citroën, Mercedes-Benz, Ford, AP Grayson and others applied for patents in this field. For the apex seals, the choice of materials has evolved along with the experience gained, from carbon alloys, to steel, ferritic, and other materials. The combination between housing plating and apex and side seals materials was determined experimentally, to obtain the best duration of both seals and housing cover. For the shaft, steel alloys with little deformation on load are preferred. The use of maraging steel has been proposed for this. Leaded gasoline fuel was the predominant type available in the first years of the Wankel engine's development. Lead is a solid lubricant, and leaded gasoline is designed to reduce the wearing of seal and housings. The first engines had the oil supply calculated with consideration of gasoline's lubricating qualities. As leaded gasoline was being phased out, Wankel engines needed an increased mix of oil in the gasoline to provide lubrication to critical engine parts. Experienced users advise, even in engines with electronic fuel injection, adding at least 1% of oil directly to gasoline as a safety measure in case the pump supplying oil to combustion chamber related parts failed or sucked in air. A SAE paper by David Garside extensively described Norton's choices of materials and cooling fins. Several approaches involving solid lubricants were tested, and even the addition of liquid moly, containing MOS2, at the rate of 1 cc, 1 ml, per liter of fuel, is advised. Many engineers agree that the addition of oil to gasoline as in old two-stroke engines is a safer approach for engine reliability than an oil pump injecting into the intake system or directly to the parts requiring lubrication. A combined oil-in-fuel plus oil metering pump is always possible. 58. Sealing. Early engine designs had a high incidence of sealing loss, both between the rotor and the housing and also between the various pieces making up the housing. Also, in earlier model Wankel engines, carbon particles could become trapped between the seal and the casing, jamming the engine and requiring a partial rebuild. It was common for very early Mazda engines to require rebuilding after 50,000 miles, 80,000 kilometers. Further sealing problems arose from the uneven thermal distribution within the housings, causing distortion and loss of sealing and compression. This thermal distortion also caused uneven wear between the apex seal and the rotor housing, evident on higher mileage engines. The problem was exacerbated when the engine was stressed before reaching operating temperature. However, Mazda rotary engines solved these initial problems. Current engines have nearly 100 seal-related parts. 1. The problem of clearance for hot rotor apexes passing between the axially closer side housings in the cooler intake lobe areas was dealt with by using an axial rotor pilot radially inboard of the oil seals, plus improved inertia oil cooling of the rotor interior. CWUS 3261542, C. Jones. The 5th of August, 1963, US 3176915, M. Bentel, C. Jones. A. H. Ray. The 7th of February, 1962, and slightly crowned apex seals, different height in the center and in the extremes of seal. Fuel economy and emissions. The Wankel engine has problems in fuel efficiency and emissions when burning gasoline. Gasoline mixtures are slow to ignite, have a slow flame propagation speed and a higher quenching distance on the compression cycle of 2 mm compared to hydrogen's 0.6 mm. Combined, these factors waste fuel that would have created power, reducing efficiency. The gap between the rotor and the engine housing is too narrow for gasoline on the compression cycle, but sufficiently wide for hydrogen. The narrow gap is needed to create compression. When the engine uses gasoline, leftover gasoline is ejected into the atmosphere through the exhaust. This is not a problem when using hydrogen fuel, as all the fuel mixture in the combustion chamber is burnt, which gives nearly no emissions and raises fuel efficiency by 23%. 59, 60. The shape of the Wankel combustion chamber is more resistant to pre-ignition operating on lower octane rating gasoline than a comparable piston engine. 61. The combustion chamber shape may also lead to incomplete combustion of the air-fuel charge using gasoline fuel. This would result in a larger amount of unburned hydrocarbons released into the exhaust. The exhaust is, however, relatively low in NOx emissions, because combustion temperatures are lower than in other engines, and also because of exhaust gas recirculation, EGR, in early engines. Sir Harry Ricardo showed in the 1920s that for every 1% increase in the proportion of exhaust gas in the ignition mix, there is a 7 degrees Celsius reduction in flame temperature. These allowed Mazda to meet the United States Clean Air Act of 1970 in 1973, with a simple and inexpensive thermal reactor, which was an enlarged chamber in the exhaust manifold. By decreasing the air-fuel ratio, unburned hydrocarbons, HC, in the exhaust would support combustion in the thermal reactor. Piston engine cars required expensive catalytic converters to deal with both unburned hydrocarbons and NOx emissions. This inexpensive solution increased fuel consumption. Sales of rotary engine cars suffered because of the oil crisis of 1973, raising the price of gasoline, leading to lowering of sales. Toyota discovered that injection of air into the exhaust port zone improved fuel economy, reducing emissions. The best results were obtained with holes in the side plates. Doing it in the exhaust duct had no noticeable influence. 47. The use of a 3-stage catalysts, with air supplied in the middle, as for 2-stroke piston engines, also proved beneficial meeting emissions regulations. 62. Mazda had improved the fuel efficiency of the thermal reactor system by 40% with the RX-7 introduction in 1978. However, Mazda eventually shifted to the catalytic converter system. 6. According to the Curtiss-Wright research, the factor that controls the amount of unburned hydrocarbon in the exhaust is the rotor surface temperature, with higher temperatures producing less hydrocarbon. 63. Curtiss-Wright showed also that the rotor can be widened, keeping the rest of engine's architecture unchanged, thus reducing friction losses and increasing displacement and power output. The limiting factor for this widening was mechanical, especially shaft deflection at high rotative speeds. 64. Quenching is the dominant source of hydrocarbon at high speeds, and leakage at low speeds. 65. Automobile Wankel rotary engines are capable of high-speed operation. However, it was shown that an early opening of the intake port, longer intake ducts, and a greater rotor eccentricity can increase torque at lower RPM. The shape and positioning of the recess in the rotor, which forms most of the combustion chamber, influences emissions and fuel economy. The results in terms of fuel economy and exhaust emissions varies depending on the shape of the combustion recess, which is determined by the placement of spark plugs per chamber of an individual engine. 66. Mazda's RX-8 car with the Renesys engine met California state fuel economy requirements, including California's low-emissions vehicle, LEV, standards. This was achieved by a number of innovations. Exhaust ports, which in earlier Mazda rotaries were located in the rotor housings, were moved to the sides of the combustion chamber. This solved the problem of the earlier ash buildup in the engine, and thermal distortion problems of side intake and exhaust ports. A scraper seal was added in the rotor sides, and some ceramic parts were used in the engine. This approach allowed Mazda to eliminate overlap between intake and exhaust port openings, while simultaneously increasing the exhaust port area. The side port trapped fume-burned fuel in the chamber, decreased the oil consumption, and improved the combustion stability in the low speed and light load range. The HC emissions from the side exhaust port Wankel engine are 35–50% less than those from the peripheral exhaust port Wankel engine, because of near-zero intake and exhaust port opening overlap. Peripheral ported rotary engines have a better mean effective pressure, especially at high RPM and with a rectangular-shaped intake port. 67, 68, 69. However, the RX-8 was not improved to meet Euro 5 emission regulations and was discontinued in 2012. 70. Mazda is still continuing development of next generation of Wankel engines. The company is researching engine laser ignition, which eliminates conventional spark plugs, direct fuel injection, sparkless HCCT ignition and SPSI ignition. These lead to greater rotor eccentricity, equating to a longer stroke in reciprocating engine, with improved elasticity and low revolutions per minute torque. Research by T. Kono proved that installing a glow plug in the combustion chamber improved part load and low revolutions per minute fuel economy by 7%. 71. These innovations promise to improve fuel consumption and emissions. 72. To improve fuel efficiency further, Mazda is looking at using the Wankel as a range extender in series hybrid cars, announced Tom.
Okay.
Mazda has undertaken research on HCCI ignition for its Skjokta rotary engine project.
I did it again, I clicked by mistake. You have to read page by page. Long time, very long time. This will record 56 minutes. Yes, but we can take a break, take something to drink. But this camcorder was full of power. Now it's 3 p.m. Yes, many weeks ago and months I made a video every week, many days in English vlog, have a good Friday or something like that. I think I'll do that again today, but when I'm finished reading this and I find a lot of good new PDF documents. So in the end of this one I have to make a new reading list. I find some more you need to read about Mazda and Audi and piston engines, and this Wankel engine, the person, the name, this man did invented, and a lot of other stuff, and Audi and BMW, Mercedes, Ford, and do some car companies. Of course, they mention Mazda, Toyota. Mazda, Toyota, Auto, BMW, Mercedes, Opel, and I think we should do Harley Davidson, but that's not a car company, but we're doing some companies. And I got one more subscriber, 15,000, but the videos to split in a few minutes. So but this is only page 12 for 40. Yes, so that will take yes, the whole summer, rest of to the autumn. No, maybe rest of this year, I don't know, but then I have something to do. Need to read about Mazda, Toyota and stuff, but I'll look at that when I finish reading this. I'm reading this same time.
Mazda is still continuing development of next generation of Wankel engines. The company is researching engine laser ignition, which eliminates conventional spark plugs, direct fuel injection, sparkless HCCT ignition and SPSI ignition. These lead to greater rotor eccentricity, equating to a longer stroke in reciprocating engine, with improved elasticity and low revolutions per minute torque. Research by T.Cono proved that installing a glow plug in the combustion chamber improved part load and low revolutions per minute fuel economy by 7%. 71. These innovations promise to improve fuel consumption and emissions. 72. To improve fuel efficiency further, Mazda is looking at using the Wankel as a range extender in series hybrid cars, announcing a prototype, the Mazda 2 EV, for press evaluation in November 2013. This configuration improves fuel efficiency and emissions. As a further advantage, running a Wankel engine at a constant speed gives greater engine life. Keeping to a near constant, or narrow band, of revolutions eliminates, or vastly reduces, many of the disadvantages of the Wankel engine. 73. In 2015 a new system to reduce emissions and increase fuel efficiency with Wankel engines was developed by UK-based engineers AIE, UK, Limited, following a licensing agreement to utilise patents from Norton rotary engine creator, David Garside. The CREEV system, compound rotary engine for electric vehicles, uses a secondary rotor to extract energy from the exhaust, consuming unburnt exhaust products while expansion occurs in the secondary rotor stage, thus reducing overall emissions and fuel costs by recouping exhaust energy that would otherwise be lost. 51. By expanding the exhaust gas to near atmospheric pressure, Garside also ensured the engine exhaust will remain cooler and quieter. AIE, UK, Limited is now utilizing this patent to develop hybrid power units for automobiles, 53, and unmanned aerial vehicles. 74, laser ignition. Traditional spark plugs